We've now created an NPC character that can follow a patrol route by using an animated destination object. But of course, patrolling is not the only thing that this enemy character should do. There's a whole range of other behaviors that we should encode into the AI. So for example, this character should begin the level by patrolling around, but then when they see the player character, they should chase them and then eventually attack them if they catch up to the player. Now, to support this range of different behaviors, we're going to have to resort to a script file. We're going to be coding more into the AI enemy class. Now, we're going to be using FSMs, or finite state machines, and I want to explain how they work and what they are. So in short, when we think about the range of different behaviors this enemy character has, they should patrol around. Now, if they see the player character, they should chase us. If they catch up to the player, they should attack the player, but sometimes the player might be successful in outrunning the enemy. Now, when that happens, the enemy should try to chase the player, but if they lose sight of the player entirely, then the enemy should go back to patrolling. What we can see here are three main states for the enemy character, a finite number of states. These are patrol, chase, and attack. And we can also see different rules or conditions governing when one state should change to the other. For example, the enemy character should change from patrolling to chasing when they see the player character. Now, the total range of these states possible and the rules that govern when one state should change to another is called a finite state machine. And this can produce some significant AI behaviors. And I want to go to the script file now inside MonoDevelop and get started at coding this AI enemy script to support a state machine. So I've jumped over to MonoDevelop here inside the AI enemy class, and we can see the code that we have already, which is used to chase the patrol destination. So we have the navmesh agent component and the patrol destination. Now, there's nothing wrong with this functionality just yet, but I want to begin to adapt this class to support a state machine. So the first thing I want to do is to code an enumeration that lists all the states possible for the enemy. So I'm going to insert a new line here, and I'm going to add public enum, and I'm going to call this enumeration enemy state. And I'm going to list the states that we have. Well, we have patrol, we have chase, and we have attack. So let's add that enumeration into here. In addition to this, we're going to need a variable that is going to store which state the enemy is in right now. So to do that, I'm going to create a new variable, private, and it's going to be of type enemy state here. And I'm going to call this current state. And I'm going to make sure that the first letter here is lowercase, so current state. And I'll give this the initial value of enemy state dot patrol. And I'll say that is the default state for this enemy character here. So that's looking pretty good. We now have a range of all the states supported, and we also have a variable to keep track of the current state that we're in right now. Now, of course, the job of a finite state machine is to manage these states and to change between them. So I'm going to move forwards with that in the next video.